Hey everybody, this is Justin Rogers from Implement's blog. Let's talk about creating static factory methods in Java. So what is a static factory method? As the name implies, it's a static method, and it returns an instance of the type that the method is defined in. Okay, but how can we use this to our advantage? There are three main benefits. Make our APIs more descriptive, cache object instances, return special implementations. Let's go into more detail. Make our APIs more descriptive. Unlike constructors, a static factory method can be given a name that's more descriptive of the type of object being created. Take, for example, the classes in the java.time package, in particular local date. If these were the constructors of local date, would it be clear without reading the Java docs what they were doing? They are instead written as static factory methods, which makes their intent much more clear. Cache object instances. Singletons. Another interesting technique is that static factory methods don't have to return a new instance each time, they can return a cached object. Some static factory methods in JDK only return a single instance. For example, in the collections utility class, the methods emptyList, emptySet, and emptymap each return a single instance of an object. So does optional.empty, and there are many others. Cache object instances, object pools. If we can cache one instance, why not cache multiple? This is exactly what the primitive wrapper classes do. If you look under the hood of some of the primitive wrapper classes, you can see that the byte, short, character, integer, and long all cache instances between -128 and 127. However, this cache is only used when the value of method is called and can't be used when the constructors are called. In fact, all primitive wrapper constructors have been deprecated in Java 9 because of this. So why is the JDK written like this? For any given primitive value, you would expect that if n equals m, then n and m are the same value. Ideally, this should be true for all the wrapper types as well, but now we're comparing object references instead. This range from -128 to 127 is actually baked into the Java language specification for integer, boolean, and character. So in other words, the primitive wrapper object caches are used to make the semantics of primitives and primitive wrappers more in line with each other. Cached object instances, performance. Another common reason you'll hear for using an object pool is to improve performance. Be careful when you hear the sirens of performance calling. If creating an object is expensive, it may be worth caching it, but these days the JVM is actually really good at creating and destroying short-lived objects. If you think you need to cache instances for performance reasons, you need to be able to actually measure the impact. At the very least, starting out with static factory methods makes it easier in the future to switch to cached instances if you need to. Return different implementations. Most of the examples I've shown so far were concrete classes that return instances of themselves, but where this technique really shines is in the ability to return different implementations. Take, for example, Java's Collections API. First, let's look at the list interface, whose most common implementations are ArrayList and LinkedList. If you were writing this API, where would you put static factory methods that return instances of lists? That's right, you'd put it in the Collections utility class. Putting static factory methods in utility classes is actually a common workaround that's due to the limitations of earlier versions of Java. Before Java 8, static methods were not allowed in interfaces. To get around this, programmers created utility classes filled with static methods. There are many static factory methods in collections for creating a list. A few are collections.emptyList, which we've seen before, collections.singletonList, which is a list that guarantees only having one element, and collections.unmodifiableList, which returns a list that can't be added to or removed from. This pattern of methods exists for the other collection types too, map and set. But let's go back to lists. None of these methods return an instance of ArrayList or LinkedList. Instead, each has its own specific implementation of list that satisfies the contract of the method. For example, the emptyList method returns an instance of a private class, called emptyList, which will throw an exception if you try and make it non-empty. Similarly, for SingletonList has its own private class called SingletonList, and UnmodifiableList has its own private implementation called UnmodifiableList, both of which will throw exceptions if you try and violate the contract of a SingletonList or an unmodifiableList. Another static factory method is the arrays.asList method. It is extremely common to see lists instantiated with this method. For example, arrays.asList S1, S2, S3. However, this method wasn't actually intended to be used this way. It is meant to bridge the gap between lists and arrays, so the list behaves like an array does. You can't add beyond the end of that list, and you can't remove from the list, but you can set an element within the list, meaning that it's not immutable. And since this is just a bridge between the array and list data types, there's no equivalent slick way to instantiate a map or a set. There's no arrays.asMap or arrays.asSet. In any case, a more robust way of instantiating a list would be collections.unmodifieablelist arrays.aslist s1, s2, s3. That way the list is at least immutable. Fortunately, we now have a better way. Thanks to Java 8 allowing static methods and interfaces, Java 9 added static factory methods to the list, set, and map interfaces, directly into the interfaces themselves, where it makes more sense for them to be. This finally gives a more robust way to instantiate instances in one line. These are the of static factory methods, list.of, set.of, and map.of. Essentially, you can instantiate a list, map, or set of any length. So now we can write this as list.of s1, s2, s3, which is way more clear. The list.of methods can actually be seen as replacing a lot of the static factory methods in the collections utility class we mentioned earlier. Collections.emptyList becomes list.of with no arguments. Collections.singletonList becomes just collections.of with a single element. Collections.unmodifieablelist, arrays.aslist, just becomes list.of with however many elements. The same is true for set and map. That about does it for static factory methods. I hope you can find places to use them in your own project. Thanks for watching.